Okay, this is the Algebra 1 lesson on section 3.5. We're going to look at solving inequalities with variables on both sides. Let's do our warm-up first. Okay, so we're going to solve for x. Now, since we have variables on both sides, we need to collect them on the same side. So I'm going to move this 7x over to the other side. And I'm going to write over here. That becomes negative 5x equals 15. Now I just need to divide by that negative 5 to get rid of it, and x equals negative 3. Okay? On this next one, I've got y's on both sides, and then I've got constants on both sides. So again, I need to collect the same terms on the same side. So I'm going to move this 2y over, and I'm going to kind of do two steps here. I want you guys not to always do this because I want it to be shown in separate steps. And then, so I'm moving the 2y over to the left side, and then I'm going to move this 21 over to the right side. So then I get 5y equals 25. And now I can just divide by 5, and y equals 5. Sorry, I've got a little bit of a cold here. Okay, for this next one, and before I can start solving, I need to distribute. Okay, so I'm going to get 6z plus 2 equals negative 2z minus 6. Okay, now I'm going to move this 2z over to the left side by adding 2z to both sides. And I'm going to move this 2 over to the other side by subtracting it. So then I'm going to get 8z equals negative 8. Divide both sides by 8. And then I get z equals negative 1. Okay, same thing on this next one. I need to distribute the 3 first. So 3p minus 3 equals 3p plus 2. Now if you notice, whichever way I move these p's, if I subtract this 3p from the left side, they're just going to go away. So they're completely going to be gone, and I'm going to have negative 3 equals 2. Well, in a normal equation, that can't happen, so this is no solution. Okay, finally, let's solve and graph this last inequality. Before I can solve it, though, I need to distribute this 5. So I'm going to have 10 minus 5b is greater than 5 squared is 25. I'm going to rewrite this over to the side so I have more space. So 10 minus 5b is greater than 25. I'm going to move my 10 over. So I have negative 5b is greater than 35. And then, actually, I just made a mistake. Let's fix that. Obviously, we should not add 10 because that is not the inverse operation. We need to make sure that we subtract 10. Mrs. Foley just had a moment. Okay, so 15. Now divide both sides by 5, negative 5. And b is, what are we going to do? Well, we're going to flip the sign since we divided by a negative number. So b is less than negative 3. So over here on the number line, I'm going to do an open circle. And if b is less than negative 3, it's everything to the left. Okay? All right, so today, like I said, we're going to look at inequalities that have variables on both sides, kind of similar to what we just did in the warm-up with equations. Some inequalities have variable terms on both sides of the inequality. We can solve these just like we solved equations in the warm-up by collecting everything on one side. And all we're doing with that, again, is we're using our inverse operations. Okay, so let's do an example. Y is less than or equal to 4y plus 18. Well, I want to get all my y's on one side, so I already see that I've got a y over here on the left, so I'm going to move this 4y over. So the inverse operation is to subtract 4y. So now I'm going to have a positive y and a negative 4y. That becomes negative 3y is less than or equal to 18. Now to get the y alone, I just divide by negative 3. Since I divided by a negative number, I need to flip the sign. So now my answer is y is greater than or equal to negative 6. So I'm going to do a closed circle at negative 6, and it says y is greater than or equal to. So it's everything to the right. Okay, so 4m minus 3 is less than 2m plus 6. I'm going to get my m's. I'm deciding I'm going to get my m's on the left side, so I'm going to move this 2m over and be left with 2m minus 3 is less than 6. Now I'm going to move this, or not move that. I'm going to move my 3 over by adding. Okay, so then I get 2m is less than 9. If I divide both sides by 2, I'm going to get m is less than 9 halves. Okay? To graph it, this is a nice graph. They actually have some fractions on it for us. So I'm going to do an open circle at 9 halves. And it says m is less than. So that means it's everything to the left. Okay? All right, so now we're going to try a word problem. So bear with me. So the home cleaning company, this company, charges $312 to power wash the side of a house, but they also charge $12 for each window on top of that. This other company, the Power Clean, charges $36 per window, and the price just includes power washing the siding. So we want to figure out how many windows must a house have to make the total cost from the house cleaning company, the first one, less expensive than the second company. And we're going to use W as our variable for the number of windows. Okay, so the home cleaning company we know charges $312 plus they charge $12 for each window. So we're going to add 12W because it's 12 times the number of windows. So that company, however much it's going to end up costing for your house, is going to be 312 plus 12 times however many windows we have. And it says that that needs to be less than the other company, okay? So that means it's going to be less, okay? Now the other company charges just $36 per window. So 36 times W, however many windows there are. So this is our inequality. Now we can solve for W. I'm going to move my 12 over to the other side. 312 is less than 24W. Divide both sides by 24, and I'm going to write over here on the side. So now 312 divided by 24 comes out to 13 is less than W. That means that there needs to be greater than 13 windows in order for the home cleaning company to be less than the power clean company. Okay, if there's anything less, if there's 13 windows or less, the other company, the second company, is a better deal. But if there's more than 13 windows, then the first company, the home cleaning company, is a better deal. Okay, so just note that you may need to simplify one or both sides of the inequality before solving it. So that means looking for like terms that combine, or using the distributive property before you can collect your variables and constants on the same side. Okay, so here we go. Before I can start moving things, I've got variables on both sides. I need to first distribute this 2. So 2k minus 6 is greater than 6 plus 3k minus 3. Now, I'm going to get all my k's on the left side, okay? So I'm going to move this 3k over, and that gives me negative k minus 6 is greater than 6 minus 3. I'm going to combine my like constants on this right side, so 6 minus 3 is 3. Now I'm going to add my 6 over to get rid of it. So I've got negative k is greater than 9. Okay, let's think about this. Am I done? No, I'm not done. So we still have a negative floating out in front of the k. So if you think about it, that's like a negative 1. So I need to divide this side by a negative 1. And since I'm dividing by a negative number, I'm going to write it over here, I have to flip the sign. So now I have k is less than negative 9. If we graph it, here's a negative. Remember, my negative numbers, the absolute values get bigger going left, even though they're still technically getting smaller. I'm going to do an open circle at 9, and then it says k is less than. So that means we're going to color everything to the left. Okay, next example. 0.9y is greater than or equal to 0.4y minus 5. Well, I want to collect all my y's on the left side, so I'm going to move this 0.4y over. That's supposed to be a 0.4. 0.9 minus 0.4 comes out to 0.5y is greater than or equal to negative 0.5. To get rid of the 0.5 next to the y, the inverse operation is to divide by 0.5. And y is greater than or equal to negative 1. Negative 0.5 divided by 0.5 is negative 1. Make sure we don't flip the sign on this one because we're dividing by a positive number. So at negative 1, I'm going to do a closed circle, and it says y is greater than or equal to, so it's everything to the right. Okay, when you get a true statement for inequalities, like if you end up with 3 is less than 4, that means that all real numbers are a solution to that inequality. If you get a false statement when you're done solving, like 0 is less than negative 8, that's not true, so there are no solutions. Because sometimes we're going to end up with no variables left over, kind of like we do when we're solving equations. And so we need to look at what's left, and if that leftover inequality is correct, then that means there's all solutions, all real numbers are solutions. If it's not correct, there are no solutions. So just note, if both sides of an inequality are fully simplified and the same variable term comes up on both sides, that means they cancel out, and then we need to look at the inequality left. So I think this will make more sense if you just see a problem. So here we go. You see 2x on both left and right side. Now, if I'm going to move one of those 2x's over, let's say I'm going to move it over to the left, they're just going to go away. And I'm going to be left with negative 7 is less than or equal to 5. Now, normally in an equation, we would just say no solution. But in this case, we need to check, is negative 7 less than or equal to 5? Yes, it is. So in that case, we say that the solutions are all real numbers. So it's not no solution because negative 5 is in fact less than or equal to 5. Negative 7 is in fact less than or equal to 5. So let's look at one example where this is not the case. Okay, before we can solve, we need to distribute. So 6y minus 4 greater than or equal to 6y plus 21. So we've got 6y minus 8 greater than or equal to 6y plus 21. I just combined these two like constants. Okay, I see a 6y on both sides. That means when I subtract one of them, they're both going to go away. So I'm left with negative 8 is greater than or equal to 21. All right, we need to check, is this inequality true? Is negative 8 greater than or equal to 21? No, that is not true. So therefore, this is no solution. So again, you can't decide if it's a no solution inequality until you check at the end if it's actually a true statement. And that is all.